Section 7.1, applications of right triangles. Even though a lot of this section is going to be word problems, it's not going to be so bad. It's mainly right, well, it's all right triangles really. All right, so first thing about this is capital letters will be used to denote angle measures, okay? Lowercase letters will be used to denote the length of sides of a triangle. And the lowercase a will be directly across from the uppercase A, the lowercase c, which in this case would be there, across from the uppercase C, and the lowercase b across from the capital B, okay? All right, so this first example says solve this triangle. We have a right triangle here, okay? So I need to find all the unknown sides, all the unknown angles. So let's find inside A, find inside B, and finding angle B, okay? So I'm going to start by finding angle B. Finding angle capital B, okay? How do I go about finding angle B? Well, I know that's 28 degrees is angle A. I know this is 90 degrees here. So angle B will be, how many total angles in a triangle? 180. I'm sorry, how many total degrees in the interior angles of a triangle? 180. So I'm going to say B is going to be 180 minus 28 minus 90. Minus 28 degrees minus 90 degrees, okay? So again, how do we do that? Angle B is 180 minus 28 minus 90. Okay, so 180 minus 90 gives me 90. And 90 minus 28 gives me what? 62? All right, so angle B is 62 degrees. All right, next, I found this part right here, right? Next, let's find A and let's find B. All right, doesn't matter which one you go with first. Maybe I'll go with A. I'm going to say finding lowercase a. Now I could use my trig functions to find lowercase a. All right, if I know this ain't going to be 28 degrees, what could I say? I could say the sine of 28 degrees is opposite over hypotenuse, or the sine of 28 degrees is opposite side, which is A, over hypotenuse, which is 15. Now you could have used this and said, okay, that's 62, and you could have used cosine and so forth. But either way, you'll get there. All right, let's multiply both sides by 15. So we have 15 times the sine of 28 degrees is equal to A, or A is equal to 15 sine of 28 degrees. And when we put this in our calculator, it's wanting us to round anyway. But whenever we put this into our calculator, make sure your calculator's in degree mode. Remember how to do that. Go to mode, go down to degree, hit enter. If I do this, I get A is approximately 7.0. 7.0. All right, so I found B. I found A. What's left? Lowercase b, right? So I need to find side lowercase b. How do we find side lowercase b? A multitude of ways now, okay? One way I could do it is I could use that angle A that was given to me, and I could say the cosine of this angle is adjacent over hypotenuse. So the cosine of 28 degrees, cosine of 28 degrees is equal to opposite side, which is B, over hypotenuse, which is 15. Multiply both sides by 15, and you get 15 times the cosine of 28 degrees is equal to B. And if you put this in your calculator, you should be now in degree mode. And if you put that in your calculator, you should get something like about 13.24. All right, so I'm going to list everything as far as my answer goes right here, okay? So what I come up with here, capital B or angle B was 62 degrees. Don't forget your unit here. Came up with lowercase a. Lowercase a is approximately 7.0. And lowercase b I came up with over here was approximately, what did they tell me to round to in this one? They did not tell me, but we're going to round to the nearest tenth there, 13.2. Now, do we have any units here for the side length? No, because they give me the side length without a unit here. So, there we go. That triangle now is solved because I found all the unknown angles, all the unknown sides. All right, let's move on to our second example. Our second example, they talk about a swimming pool and so forth. I'm not going to write down the whole problem here. I'm just going to draw the picture and then work the problem. You'll have it in the notes anyway. All right, so for my second example, I have a swimming pool that looks something like this. It's 4 feet deep here on the shallow end, and then it slopes down like this. Then over here on the deep end of my swimming pool, it's 8 feet like that. Now, they have something else here. They have something that's given to me like this. They say that we have an angle right here of 5.7 degrees, okay? Now let me see what's going on. I say swimming pools, they depth about 4 feet at the shallow end, 8 feet at the deep end. The bottom of the pool slopes downward at an angle of 5.7 degrees like this. Okay? How long is the pool? Round to the nearest foot. So I want to find how long is this pool right here? What is this length right here? What is the length from here to here? All right, so the way I'm going to go about doing this is I'm going to extend this little dash line to go across like that. And if I make it to go across like this, I'm going to have a triangle right here on the bottom portion with a 90-degree angle right there, right? So I have a triangle with a 90-degree angle right there. All right, so now, what do I know about this triangle? I know this triangle right here has a 90-degree angle. I know it has an angle of 5.7 degrees, right? But what do I know about the length of this side right here? Remember what the 8 feet was, or what the 8 feet is. Actually, the 8 feet is what? From here to here, right? So what would from here to right here be? What would that length be of my triangle? Well, if this whole thing is 8, and I take away this much right here, I should be left with that much, right? So if this whole thing is 8, then I take away this much, I'm taking away what? 4 feet. So what's 8 feet minus that 4 feet? That'll give me 4 feet right here, right? All right, so what are they wanting here? They're wanting this length right here, right? Isn't it the same as this line right here? It's just moved up. So I can call this maybe like L right here for length. There's some unknown. It doesn't really matter what you use. So let's find that length using this right triangle right here. Well, could I say that the tangent of 5.7 degrees is opposite over adjacent? Yeah. So I'm going to say the tangent of 5.7 degrees is equal to opposite, which is 4, over adjacent, which is L in this case. So now let's just solve this for L. So we're going to multiply both sides by L. So we have L times the tangent of 5.7 degrees is equal to 4. Still need to solve for L. So we're going to divide both sides by the tangent of 5.7 degrees. So L is going to be 4 over the tangent of 5.7 degrees. All right, now it turns into a calculator problem. If I go ahead and put this in my calculator, I get something like 0.07. All right, this says round to the nearest foot. That was my length right there. So my length to the nearest foot is going to be what? 40 feet. Look at this. 40 feet. Yeah, these problems aren't so bad. All right, next we're going to look at the bearing of an object. Now, what do I mean by the bearing of an object? I mean, okay, is it going northwest? Exactly how northwest is it going, and so forth, like a ship or a plane or whatever, you know. How far northeast or northwest is it going? Okay? Your book says the bearing from point A to point B is the degree measured at acute angle formed by the ray AB in the north-south line. For example, suppose this is a compass. We have north, south, east, and west on it, right? All right, let's see. What if I have an object that starts right here and goes this way, okay? We'll go ahead and call this point A. We'll go ahead and call that point B, okay? And then we have 50 degrees right here. Now, yeah, this object's traveling northeast, right? But the bearing, the way they do it in this book is they say it's going to be the acute angle between the north or the south. Well, if I go between the south in this ray right here, I don't get an acute angle. But if I go from the north right here to this ray, I get an acute angle, right? And the way we denote this is we use the north direction first, and then we put 50 degrees in between it, then we put east, okay? All right, so for example, let's suppose that we have something like this, north, south, east, and west, okay? And let's suppose I have an object that does this. Goes from point A to point B right here. And this is, let's say, 50 degrees right here. What is that bearing of that object if it's moving that way? Well, we look at the acute angle between the north or the south. This is the acute angle between west, right? The ray and west. We want the acute angle between the ray and south. So we actually want this angle right here. So what would this angle be? Well, this whole thing right here, from west to south is 90 degrees, right? So what's 90 degrees? Like if I go from here to here, that's 90. What's 90 minus 50? 40 degrees is what I want. Now, you want your north or south to be first. In this case, it's south for your bearing. Then you put your degree measure, 40 degrees, and then if it's east or west. This one is west. So that's south, 40 degrees west. All right, so let's use that information to find some stuff here. All right, our next example says a ship goes for 16 miles heading north, 27 degrees west. So what I'm going to do is I'm going to draw me a little picture here, okay? Here's north, here's south, here's east, here's west, okay? Now what's it say? It's going north 27 degrees west. So it's going northwest, but the acute angle formed by that ray in north needs to be 27 degrees. So I'm going to draw something like this. 27 degrees right here. Like that. All right, then what's it say? The ship makes a 90-degree clockwise turn. So it's going clockwise at turn. Makes a 90-degree turn. And it starts going like this. Okay? And what does it do? Ship makes a 90 degrees clockwise turn to a bearing of 63 north, 63 degrees east for 11.2 miles. All right, so my ship does like that. And that's 11.2 miles. And what did it say that first, how far did it go for that first part of the trip? It went 16 miles, right? All right, then what did they say? Find a bearing required for the ship to return to port. So I want to know, okay, for my ship to turn around and go back to where it started, back to port, it's going to need to do something like that, right? So I need to find the bearing. I need to find out which way is going to hit it when it returns. It's going to be headed when it returns back to port. Let me go ahead and put my 90-degree angle right here because it said it took a 90-degree turn. All right, I'm going to extend this purple line. And I'm going to put it like that, okay? Because I like to use that origin right there in my compass to determine the bearing. All right, so what do I know here? I know that we have 27 degrees right here, okay? This angle between this ray and the north axis here is going to be 27 degrees. I know the length of this side of my triangle. I know the length of that side of my triangle, right? So what do I need to find? I need to find what is the bearing to return home. So what I'm really looking for is I'm really looking for this angle right here, the acute angle between this ray and the south axis. All right, how can I find that? Well, let's find what this angle right here is, okay? Let's find out what that angle right there is. Let's see, how can I find that angle right there in my triangle? So this angle right here in my triangle. Well, couldn't I do something like, call it some name first of all, maybe like theta, okay? So maybe I'll call this angle theta. Let me use a trig function to find it. If I'm looking at this as theta, and this is a right triangle, isn't this part, the purple part, my hypotenuse? So if I use a trig function to find theta, I would need what? This side over that side, or vice versa. So what would that be? That would be opposite over adjacent with theta, right? So I'm going to be finding theta, and I can say that the tangent of theta is equal to 11.2 over 16, right? All right, now how could I find out what this measure of theta is right here? I could use the inverse function, because this says what? Theta is the angle that whenever I take the tangent, I get this number, right? So if theta is the angle whose tangent is that number, I could say theta is the angle whose tangent is 11.2 over 16, or theta is equal to the inverse tangent of 11.2 over 16. All right, so if I do that, I get something like, I don't want to bore y'all with punching stuff in the calculator, but I'll get 34.9920 degrees if I calculate that. So theta is going to be what? 34.9920 degrees. All right. So what does that do? That allows me to find this little acute angle right here. And maybe I'll go ahead and call that little acute angle alpha, okay? How could I find that alpha? How could I find this little bitty alpha right here? I could say theta, but subtract this much of theta right here. That much of theta right there. If I subtract that much of theta, I'm subtracting 27 degrees from theta, right? So wouldn't it be this 34 number minus 27 will give me alpha? All right, so if I'm finding alpha, I'm going to say it's going to be theta, which is 34.9920 degrees minus that 27 degrees. Okay, so what do I get whenever I subtract this? That gives me something like 4, 5, 6, 7.9920 degrees. Now, I'm not going to mark that right there because that's just too small to put in there and I'm getting too much stuff in there, okay? Now, what do we know about this angle alpha right here and this angle right here? They're what we call vertical angles. Think back to elementary school. You had angles like this. Say this was angle 1 and say this was angle 2. Those are vertical angles like that, and angle 1 was congruent to angle 2, right? And the same thing here. Angle 3 is going to have the same measure as angle 4 because those are vertical angles. Angle alpha is a vertical angle with this angle, so it's going to have the same measure. So this one will be 7.9920 degrees right here. And what do they want me to round this to? Find a bearing required for the ship to return to port. Go ahead and round it to the nearest whole number, okay? So what's a bearing? Remember how I need it? I need 8 degrees, but I need it smashed between two things, right? What does it need to be smashed between? South and what? West in this order. South, 8 degrees, west. Here's my bearing. South, 8 degrees west. All right, so that's all we're going to have for the lecture today, and then we'll pick up after the holiday.